Hello and welcome back to Crash Course Statics. Sorry for the delay in this episode. I've had quite a semester so far, but it's spring break now, so I'm finally working on videos again. Like I said in the first episode, this video will be looking into structural failures. Since that video, there has actually been a bridge collapse in Miami. You've probably heard about it, so I can't really make this video without at least mentioning that disaster. As of the time of me making this video, the Miami collapse is still under investigation, so I can't really say anything definitive about it. I did work with my brother to create a model of the bridge, and we analyzed the stress on it. This revealed that there was one member which was under a lot of stress, but after doing some more research, we found that this area had actually been reinforced, and it wasn't even the place where the bridge broke. So our surface level design analysis indicates that the bridge was probably properly designed and the failure might have come from somewhere else. I won't say anything more than that because it would just be speculation, but I will try to make a video when the official report is released. Now, back to the original plan for this video. In 1981, a suspended walkway or sky bridge collapsed and killed 114 people and injured another 216. This happened in Kansas City at the Hyatt Regency Hotel. There were 3 walkways in the hotel that connected the 2nd, 3rd, and 4th floors in different parts of the hotel. The 2nd and 4th floor walkways were stacked on top of each other while the 3rd was set off to the side. The design originally called for rods to pass through the 4th floor bridge to connect to the 2nd story bridge. This would mean that each rod would hold weight from both of the bridges. The problem with this design was that it required nuts to be threaded all the way up a rod to where the higher bridge would be held. The construction company understandably did not want to thread nuts up 2 stories worth of rod, and they were also worried that they could easily damage the threads on the rods when they were installing these walkways. Because of these concerns, an alternative plan was proposed, which split the rods into 2 so that only the ends needed to be threaded. This plan was approved by engineers, who were ultimately found at fault for the disaster. This is another lesson for those wanting to be engineers. As an engineer, you will accept an enormous amount of liability. Even if it's someone else's design, like the Hyatt Bridge was, you are still accepting responsibility when you sign off on the design. And even if you don't get in legal trouble, you can still lose your engineering license for poor practice. Engineering organizations have strictly enforced ethics codes which you should really study before working as an engineer. Ultimately, this is done for the safety of the public, and it seems to have worked because deadly structure collapses are still fairly rare in the United States. So let's get into why the engineers were found at fault for the Hyatt collapse. When they reviewed the plan, they did not do an effective analysis of the design, and the existence of a massive design flaw suggests that they hardly considered it when signing off. This design flaw was an unavoidable side effect of using 2 rods instead of 1. When there are 2 rods, all of the weight from the bottom floor is placed on the beam for the upper floor. This force is then transferred through the beam to the single nut that is holding that beam up. If the rod had gone straight through as designed, then the rod would hold weight from both floors, but the beam would not. By changing the design, the strength of the bridge was effectively cut in half. This means that if too many people stood on it, it was bound to collapse. That's exactly what happened on July 17th in 1981. Approximately 40 people were standing on the lower bridge and 20 were on the top. They'd gathered there to watch a dance which was taking place below the bridges. The added weight of 60 people was too much and the nuts were literally pulled through the beams, as you can see here. You can also see that those rods and nuts on the upper floor stayed in place. The 2 bridges fell onto the dance floor and then the upper bridge collapsed onto the lower bridge. Rescue workers had to fight their way into the building, clearing it of cement dust and also redirecting water to prevent flooding. They were able to rescue 29 people from the rubble, but in the end, 114 people were lost. Aside from the ethics lesson, the main reason I'm telling you about this story is to demonstrate how much there is to learn, which I didn't cover in the first video. I only discussed how to analyze a weightless truss at individual joints. In this case, it wasn't even a truss, and the failure happened in a beam, which requires more understanding of materials to actually analyze. Now, the second collapse I want to talk about is one where you should actually know enough to solve it. The lesson is actually about forgetting to account for everything. Now, a quick disclaimer here, this is based on an actual disaster where 7 workers were killed. However, it's been adapted to be an ethics assignment, and I'm going to adapt it even further to make it into this video. So this may not be representative of the real disaster. A TV tower is being constructed and a large section had to be lifted to the top. The company that produced the tower had designed the section to be lifted horizontally, but this made it difficult to mount the section once it got to the top. The construction company requested a redesign, but engineers refused to accept liability and told the company that they could not modify the section in any way. Ultimately, the workers decided that they should attach a bar to one of the connection points so that they could lift the section at an angle. The section only weighed 1,200 pounds, and they were using 2 bolts which could hold 1,000 pounds each, so they thought that they were pretty safe. The workers lifted the section, but partway up the tower, the bolts broke and it fell. As it did, it hit one of the supports for the tower, causing the entire structure to collapse, killing 7 of the workers in the process. Again, all of the specifics here could be entirely wrong, this is just for education. Okay, so let's look at why this hypothetical lifting failed. The bolts should have been able to hold around 2,000 pounds, and they were only carrying a 1,200 pound object. Well, the problem is that they were carrying the section at an angle, and this induced a moment. If you've seen my last video, you should know how to do these calculations, so let's take a look at the section. We don't actually need to know the angle, just how far apart the bolts and center of mass are. Let's say that the second bolt ends up being about 1 foot to the right of the first bolt, and that the center of mass is about 5 feet to the right. Because all of the forces are vertical in this situation, we can simplify this problem to points on a horizontal line. So now, let's find the load on the second bolt using our moment calculations. To eliminate the force on the first bolt, we take the moment around that point. That means that the net moment is the force on bolt B times 1 foot, plus the weight of the section times 5 feet. Because the section should be in static equilibrium, we can set this equal to 0, and then we can find that there is 6,000 pounds of force on bolt B. This is 6 times the recommended maximum load. If we balance the vertical forces, we can find that A is experiencing a force of about 4,800 pounds, again way over the recommended load. So just because your bolts should be able to hold more than the weight of the object doesn't mean that they won't break. You have to analyze the entire system before you can say it's safe. This just shows how you can make severe errors unless you've been trained and have had time to practice. So that's going to be it for this video. In the third and final episode of Crash Course Statics, I will be building an actual truss and predicting when it will break. But remember, this will not prepare you to safely design real structures and is mostly a quick look at the world of engineering. For now, I'm Hathy, and I will see you in the next video.